All right, thank you so much for that introduction. For those of you who were at the last LiliCon, if you were looking down the talk titles and if this one seemed a little bit familiar, you may have had a question like, maybe. There's different, a lot different here, or what I thought would be a lot different. So some differences between what I mentioned back in October. I thought I had this really great novel idea that no one else would have ever thought of this. I thought so until approximately 10:30 a.m. this morning, until Katie started speaking. And I realized that someone else had already done this. But I guess we'll get to see if the results are similar or if they're different. Do we get converging results, converging evidence or not? There's also a second data set I'm happy to share that I didn't have available in October. And also, I'm going to argue that this framework offers some really interesting predictions about how different messages that we're sending to our students might lead to different sort of updating of their beliefs and their behavior. All right, so here's the basic problem. There's evidence that educational news or educational games can decrease people's belief in fake news, which is good. For example, one study found that an educational game could decrease people's belief in this top headline up here about left-wing extremists, and this bottom headline down here about protests hurting Super Bowl TV ratings. Now, the problem, though, is that this bottom headline over here actually comes from The Guardian. In other words, the bottom headline is from a legitimate news source. All right, so you can see the problem is that sometimes our well-intentioned educational interventions sometimes not only decrease beliefs in what is false, but can inadvertently decrease beliefs in what is true. And you may have had this experience if any of your students have come up to you and said, oh, your course has changed the way I think about things. And now I no longer believe in X, and you could fill in X with anything you know that is already true. All right. Sometimes you also see this, for example, in if you've ever seen the documentary about people who believe the Earth is flat, and you hear statements like, "Oh, now I only believe what I see with my own eyes and my own ears." In other words, they distrust all experts, right? So this can be a kind of form of nihilism that we all want to avoid creating. So there's serious dangers to this kind of nihilistic, generic disbelief system, right? It could lead to disbelieving vaccines, disbelieving that the Earth is warming, right? And both of these kinds of disbeliefs can lead to serious loss of life. So it's important to distinguish skepticism from cynicism or nihilism. And I'm going to argue that there's a very useful theoretical framework to do this. It's a framework that has caught on recently with misinformation researchers, although the framework has been around for a long, long time. And that framework is signal detection theory. So how could you use this to apply it to what we're all interested in this room, skeptical education? All right, so imagine you've got a student, a hypothetical student, I'll just call him Zach. So Zach has a very strong belief in climate change. Zach he still believes in human evolution, but a little bit less so. Zach has less belief in the Big Bang Theory and so on and so forth. So his beliefs exist on a continuum, like most of our beliefs do. Zach also has a lower on average belief in pseudoscientific or unsupported claims, but it's an on average difference. So there's still a lot of variety of belief strengths. And so in other words, these are overlapping distributions. So there's a distribution of the signal, the distribution of belief strength in things that really are scientifically supported claims like climate change. And there's also a distribution of noise, that is a distribution of belief in things like homeopathic remedies, for example. All right, now, even though our beliefs exist on a continuum, we often have to make decisions in our day-to-day lives, right? So for example, Zach's cat gets sick and he has to decide whether to give his cat acupuncture or not. Is it worth his time or his money? And so in signal detection theory, there's a decision threshold, and anything to the left of that, anything to the right of that threshold, if we're forced to make a decision, we decide or act as if it's true, and anything to the other side of that decision threshold, we decide and act as if it is not true. All right, so because acupuncture is at the right of that threshold, Zach goes ahead and pays some money on acupuncture for his cat. Now, if skeptical education, if what it does is if it changes that threshold, if it moves that threshold to the right, now, on the one hand, that might help Zach out. Now if you move far enough to the right, now he's no longer willing to spend money on acupuncture. The problem, though, is that now it's far enough to the right that he no longer believes that the Big Bang Theory is true either. All right, so notice that moving around this threshold creates a series of trade-offs, right? So on the one hand, we want to avoid false positives like acupuncture, but on the other hand, we also want to avoid misses, right? So Zach can miss out on parts of the signal distribution that are to the left of that threshold. All right, so notice, that line in the middle is called this decision threshold. Sometimes it's called a response bias or a criterion. And the idea is you can move it to the right to reduce false positives, but it's a trade-off, right? By reducing false positives that way, you also end up increasing misses, right? And at the extreme, if you move it very far to the right, you end up with something more like nihilism, where Zach just disbelieves almost everything. Now it's starting to sound like these flat earth kind of claims that you can only believe stuff that you see and hear in your own life, and you have to distrust everything else, even your second grade teacher. All right, so is this really what we're after? Are we after moving around this threshold, or is it something else? And so my first way to try to answer this question was to try to figure out, if we could figure out, what are the canon textbooks or books that we use, then I could figure out, okay, I just have to look at those books and see what the priority is in those books, right? And that'll tell me what we're mostly interested in. All right, so I looked through the Lilienfeld Alliance syllabi in the Google Drive. Notice this is a slightly different sample than the one you heard about earlier. So the results may differ, or we might get something similar, right? So let's see what happens. So there's 70 unique courses there. And for each one, this is just a list of the required books. Was it any book earlier, or was it just it was any book? Okay. So the methods are a little different, and so you may see some different numbers here. All right, different samples, slightly different method. All right, so each bar is a different book, and the height is how many courses are requiring that book. And so I went about this approach, and I thought, oh great, I'll just find the sort of standard canonical textbook. What could go wrong with that? And the most popular, the most commonly required textbook is no required book. All right, so if you look through these syllabi, it's very common to just say, well, we're going to assign a bunch of select chapters, a bunch of select articles. All right, and I think we saw some evidence to that effect earlier as well. So that's that first highest bar. Okay, second highest bar, I swear that one really is a real book. Second highest bar, Schirmer's Why People Believe Weird Things. Next highest bar, the Schick and Vaughan textbook, Weird Things. Just in case you think there's a pattern there, I'm going to have to break that pattern next. So don't try to write a new textbook named Weird Things thinking it'll be a bestseller. All right, so the next one was Heinz's textbook. After that, Demon Haunted World hasn't been updated since 1997. Is still on that list, still has that kind of timeless power to it. The feeder textbook, that one's specific to pseudo-archaeology. That one is arguably canon for pseudo-archaeology courses. It's really common in that subspecialty kind of course. And then a handful of other books down there, including How We Know What Isn't So from 1993. Hasn't changed a word, still up there. And then there are 50 more books not shown down there. So again, I think, no matter, which sample of syllabi you look at, no matter, the details of the method have changed, but I think we're coming to the same conclusion that the answer is there really is no one standard textbook. It's really like a wide variety, an eclectic mix. Some of them are textbooks like these two here are textbooks. Some of them are general interest books. We've got new books that get updated really recently. We've got some old ones in there as well. All right, so I couldn't really get an answer by trying to find the canonical textbook. And so I said to myself, well, what are we really focused on? What are our priorities? Maybe I should just look in the syllabi themselves for some common themes. All right, and so there's more than one common themes in these. I was really focused on themes that are specifically related to the signal detection idea, and I think there is a common theme related to this, and you'll see it in examples in various parts of people's syllabi. For example, here's some learning objective examples, how pseudoscience differs from scientific inquiry, how to differentiate scientific knowledge from common sense, personal experience, and pseudoscience, distinguish between these two things, distinguish fact from fiction. You could see these kinds of examples also in course descriptions, distinguish between, separate, how do they differ, how do we discriminate between these two things. It's even in at least one course title, this same idea. So by my count, I had 40 out of the 70 syllabi have this theme in them about discriminating between fact and fiction or science and pseudoscience. And some of the ones from philosophy courses even explicitly tie this to demarcation. All right, so this is a common theme. I think in your slides it was 48% in that sample, something like that. So we're getting like a little bit above 50% or a little bit below 50%, depending on how you do it, depending on how you analyze it. All right, so this is always nice to see that we get some converging evidence across different methods. All right, so it's a nice surprise in that sense. All right, so if our goal is to increase discriminability, that's a little different from moving that decision threshold around. What that means is we're trying to get the students to separate in their minds to find that separation between science and pseudoscience. And that means moving these signal and noise distributions apart from one another. And if you move those distributions apart even just a little bit, even just subtly, you'll notice that the number of false alarms, this red area here, this false acceptance of pseudoscience beliefs can decrease. And at the same time, the misses can decrease as well. All right, so that would be a clear win if we could increase discriminability in the mind of a learner. All right, so does that actually happen? All right, so I'll show you data. This is study one data from a psychology elective course of mine. There were 30 students in there. Just to give you a sense for the content, the two required books are the Investigating Pop Psychology book and Shermer's Conspiracy book, along with a wide variety of other readings. I don't think there's anything especially novel or different about this course. I think of it as sort of a standard run-of-the-mill skepticism course. So I'm not here to brag about any kind of revolutionary new thing I'm doing in the classroom. It's really a question of measuring how students are changing from the beginning to the end of the semester. All right, so I'm taking these students, I'm going to compare them to students from another course that I was teaching, the exact same professor, also taught by me with the exact same prerequisite. So you're getting the same kinds of students who are into the class, but it's not perfect. I can't randomly assign them to one class or another. Unfortunately, my registrar's office won't let me do that. So instead, we're left with this quasi-experimental design, which is really common in this kind of area of research. So all the students get an anonymous survey at the beginning of the course and at the end of the course as well. The primary outcome measure is one that you've seen before at this conference. So we've got a bunch of supported claims, 14 supported claims like the age of the Earth is 4.5 billion years old, and 35 unsupported claims involving acupuncture, alien abduction, and so on and so forth. Everyone rates them on a 5-point scale. So in the slide on the next screen, 5 is they're totally sure it's true. 1 is they're totally sure it's false. All right, so here's the original data from Katie and Ray's original paper. This is sort of like the brief Cliff Notes summary of it. There's a lot more to it than that, but this is the Cliff Notes. So basically, students start here in the pseudoscience course at 2.6 on their belief, and they drop down to 2.0 by the end of the semester, which is good. All right, so they're disbelieving these unsupported claims like alien abductions. So all I'm showing here are the unsupported claims, right? And the research methods class, it's also a scientific methods kind of class, but it's not specifically refuting these controversial topics, and so it's not really doing anything to these belief systems. All right, so did I get something similar to happen? Yeah, pretty much. All right, so this pretty much replicates that pattern. Okay, so far, so good. Students are decreasing their beliefs in the pseudoscience class from the start to the end of the semester. But the question is why? Why are they decreasing their beliefs? Is it because that decision threshold is moving around? Or is it because they're getting better at discriminating those two distributions from one another? Or is it some combination of the two going on? All right, so this is where they started at the beginning of the semester. This is where they ended. I know it's sort of small on the screen, but you'll immediately see that that decision threshold is moved to the left. You'll also notice if you look like really, really closely, and I had to put like some dashed guiding lines so that you could see it, the distributions did move apart at the same time. All right, so here it is in the numbers. These are all in standard deviation units. So what happened is people's decision threshold had increased by 0.4 standard deviations, and the discriminability increased by 0.6 standard deviations from the start to the end of the semester. All right, so the question is like, why are they changing their beliefs? Well, it's a little bit of both. All right, now that might be good or bad depending on how you interpret it. The stats class in comparison, no effect whatsoever on either measure of change. All right, so study one found some evidence of an increase both in students' decision thresholds and in their ability to discriminate between the signal and the noise. There's some other good news. Students often report maximum belief in the supported items. So for example, overwhelmingly agreement that it's absolutely sure that the Holocaust happened, absolutely sure that, I should preface this, I teach in a conservative southern state, and yet there's widespread agreement among my students that there really is climate change and it really is caused by students. So that's good news. All right, good news as an educator, right? That's great to see. But as a researcher, the problem is they're really close to ceiling, all right? And so it's really hard to tell if maybe across the course there's beliefs might be going up or down, but if they're stuck at ceiling already, I can't tell, I can't measure it. All right, so I wanted to replicate this pattern or see if it would replicate, and along the same way, try to address this ceiling effect. So in study two, what I did was I added 21 more difficult supported items. So a couple of examples. So you see the one on top is about the magnetic north and south pole moving over time, which is true, it's a supported claim, but it's a little bit harder for students than just agreeing that, yeah, the Holocaust happened. All right, so hopefully to get away from ceiling effects, and there was evidence that that reduced ceiling effects from study one to study two. And then the question is, okay, so does this replicate after you've reduced some of these ceiling effects? So this is just replotting data from study one in a different way so you can compare study one to study two. So in study one, there was this increase in the decision threshold from the start to the end of the semester in the pseudoscience class. And you'll notice that that also happens in study two. So that pattern replicates. You get that increase in decision threshold in the pseudoscience class, but not in the statistics class. All right, so that pattern replicates. What about that increase in discriminability? Does that also replicate? And it does. So that increases from the beginning of the semester to the end of the semester, even in study two. You'll notice that discriminability is lower overall in study two than study one, but that's expected because the true items are more difficult. All right, so it is harder to discriminate between the signal and the noise when the true items are more challenging. All right, but the important thing is that that blue line is still positively sloped. All right, so pseudoscience course was associated with an increase in both a decision threshold and discriminability. This pattern was robust across two studies. I don't have time to show it today, but you also get the pattern if you use non-parametric signal detection measures. So if you relax the assumption that the signal and noise distributions are normal with equal variance, even if you relax that assumption, you get the same basic pattern of result. So we know that increase in discriminability is good, that they're able to separate the signal and noise. But the question is, like, what about that decision threshold change? Is that good or bad, right? On the one hand, I don't want my students to be so open-minded that they're making lots of false positives, and also not so close-minded that they disbelieve everything, right? But where's that Goldilocks, spot in the middle, right? Where, how's the saying go? You want to be open-minded, but not so open-minded that your brains are falling out, all right? Now, it's tempting to say dead center, right? It's very tempting to say that, but it turns out that there's a mathematical answer to this, and it's not always dead center. All right, so this comes straight out of signal detection theory. If you combine it with like a dash of utility theory, you get an equation that gives you the answer of what a rational student should do with their decision threshold. And I just want to highlight a few pieces of these because they relate to some common messages that we give to students. All right, so for example, moving the threshold to the right is actually rational upon learning that the base rate of pseudoscience is high. All right, so for example, when my students start to realize that they could walk to any old drugstore and find lots of placebos on the shelves, right, that the base rate of pseudoscience is a lot higher than they thought it was before taking the course, it's actually rational for them to increase that threshold. All right. Likewise, it's rational for them to increase that threshold upon learning that the cost of pseudoscience can be high. Right? So taking an unregulated and scientifically unsupported supplement occasionally can lead to hospitalization or death. Right? And so as they learn that, it is rational to move that to the right. However, it's not always rational to move that threshold to the right. For example, it's rational to move that threshold to the left upon learning that the cost of science denial is high. Right? So upon learning that denying the evidence for vaccines, it can be costly, it can kill you, it's actually rational to move that threshold a little bit to the left so that you're accepting more claims. All right, so this theory makes some interesting predictions about what a rational student should do upon learning different kinds of information and different kinds of messages that we're sending them in our courses. All right, of course, better yet, it'd be ideal if we could just increase discriminability, right? And there's a lot of different ways to do that. I think a really common one is to highlight features that are much more likely to occur among pseudoscientific claims than among scientific claims. All right, is one way to do that, but I think there are certainly others. All right, so in conclusion, you could use signal detection theory. It highlights the evidence from at least my courses that it can lead to both an increase in that decision threshold and an increase in discriminability. You could use this theory descriptively as a way to measure what students are doing, but you could also use it as a normative framework to make predictions about what a rational student ought to do upon learning new information, right? And at least in theory, you could imagine experiments to compare these two things. How do students change their beliefs? And is it really rational in what they're doing? All right, thank you all very much. So, time for questions? Or yeah. Yeah.
I was just curious, so in your class, when you tested individuals on the pseudoscientific beliefs after the course, these were things that were not talked about in the course in any capacity?
It's a mix. It's a mix. Some of it was covered, some of it was not. I think I went past it. All right, so the blue lines are ones I know I covered. Are you able to see those, or is it too faint? The blue lines, I know I covered them. They exist either in the lecture slides or in the assigned readings. The red ones I did not intend to cover, although with a caveat, I can't remember all my spontaneous remarks. So, you know, but so you could see, like on different topics, you could see the time course of their beliefs. Yeah. Other questions? All right, thank you very much. Oh, you got a question?
One challenge is we can use the whole course as an intervention, but how can we like zoom in and see if particular class activities or something might increase that separation or move the line? Yeah. Can we do this at a more kind of narrow scoping scale?
Yeah, I mean,
so we can figure out what are the best ways to teach.
Yeah, I think they'd have to be like smaller scale interventions, brief interventions implemented in experimental designs that you could, try to manipulate each of these pieces of that equation, for example, to see if students are responding in the way that you would hope they would respond. Yeah. Yeah. All right. Thanks.